discussing photoelectric effect. So what is the photoelectric effect? Anyone please?
Flow of electrons because of light.
When a light falls on a metal,
Flow of
the electrons will
photoelectrons.
increase.
When a light
Okay,
falls on a surface, the electrons on the surface will emit.
okay, good, very good. Okay, please mute. Okay, okay, this is the photoelectric effect. Already yesterday we have discussed. I think you understood. Okay, just Einstein also given explanation to this photoelectric effect. First, this photoelectric effect was discovered by H. Okay, once light is he took a one metal plates, two metal plates. Okay, when light falls on this metal plates, this is light, some light or photon, whatever you can say. Electrons are ejected from this metal plate. Electrons are ejected. Okay, when you connected this one to some potential or battery, anything like that. Okay, so here this is negative plate, it's cathode, and this is anode positive plate. These electrons are attracted towards the this terminal, other end. Okay, then there is a flow of electrons. These emitted electrons we are calling photo electrons, and current due to this photo electrons we are calling photo current. Okay, that is the thing. Okay, and if you increase this positive potential, if you increase this positive potential, most of the electrons attracted towards this terminal, and flow of electrons also increase. That means photo current also increase. That's why we have plotted yesterday a graph. Okay, this is photo current, and this is the voltage, some voltage. Okay, if you increase the voltage, current will increase and it is saturated. Okay, after that it is saturated. This is saturation current. Okay, and so if you increase this positive potential, most of the electrons attracted towards the this terminal. Okay, right? So you want to make this you want to stop these electrons. What you have to do, you have to reduce this positive voltage, you have to reduce this voltage. And once we make the V is equal to 0, here terminal at the terminal B voltage 0, still the electrons flow is not stopped. Okay, because some of the electrons still coming to here. And after that we reduce, we increase it negative direction. That means negative potential applied here also. Okay, here first we have positive potential here. Once you increase the positive potential, this current is increased and saturated. Okay, to stop these electrons, we are reducing the potential at B terminal. Okay, this is B terminal. Let's take this A terminal. Okay, at B terminal we are reducing the potential, and once we make 0 also, some electrons are reaching this terminal. Okay, even we reduce the this voltage to negative voltage, some negative voltage, still electrons are coming to this terminal. It is not, these electrons are immediately not stopping. Why? Because here potential is high, because already electrons are ejecting, some negative potential also we are applying. So negative potential is high compared to this B terminal. At A terminal, negative voltage is higher compared to B terminal negative voltage. That's why electrons are flowing from A to B. After that, we are further increasing. If you increase further negative direction, then at the B terminal, negative voltage is higher. Okay, in the second case, negative voltage is higher compared to A case. That time, here repulsive force is increased at the B terminal. So here also negative and here also negative. So this electron flow is stopped. Okay, that means no electrons are coming to the B terminal. So electrons are not circulating in the circuit. There is no current in the circuit. That's why we are calling that, at that potential we are calling a stopping potential, that is negative voltage. Always you remember, here we are applying some strong negative voltage that is higher than the A terminal. Okay, higher than potential at A terminal. Then these electrons are not coming to the B terminal. That stopping potential, that potential we are calling a stopping potential. To make to make to make current zero, to make current zero, or flow of electrons to stop flow of electrons, to stop flow of electrons, we are applying some negative voltage. Okay, that voltage we are calling a stopping potential. Stopping potential, it's very easy definition. You can I think you, okay, just it is stopping the current or flow of electrons. That potential or that voltage we are calling stopping potential. Is it clear, everyone? Okay.
Yes, sir.
Okay, and also we have derived the expression Einstein's explanation. Just I am going through quickly Einstein's explanation. Okay, coordination. Okay, whatever incident energy H is utilizing two ways. One is the to eject the electrons, and second part is giving some kinetic energy to electrons, to ejected electrons. That is the it is incident energy. This is HQ is the incident energy. It is utilizing two ways. One is to eject the electrons from metal surface, and second one to giving some kinetic energy to the ejected electron. That H nu is equal to, this is work function, or you can say work function, and this is some E pi. You write work function E pi in terms of electron volts, and this is the half mv square. This is some kinetic energy. Okay, from this equation you can rewrite this one, or you can write this one E h nu 0 also you can rewrite. Okay, this is half mv square. From this expression you can rewrite, just I am rewriting, h nu minus nu 0 equal to 1 by 2 mv square. Okay, mv square. Just I am only this step you have to know. After that, this is simplification, just nothing to worry here. Okay, so this is Einstein's equation, Einstein photoelectric equation. After that, you can simplify also. Here half mv square is equaling to EV0, EV0. Okay, EVSR you can write EVS, stopping potential. That is okay. This kinetic energy, how we are giving this kinetic energy? Incident light is some part is ejecting, some part is giving to kinetic energy. So here we are applying some voltage. Here we are applying some voltage to accelerate these electrons, or to attract these electrons, or to move these electrons. That way this potential energy is utilizing as to move these electrons, are utilizing as kinetic energy. So in the equation, this kinetic energy is equal to the potential energy. This is the Einstein's photoelectric effect equation. Okay, in this equation, okay, this is the, and we will go to the next step. Up to now, up to this portion we have discussed in the yesterday class. Now we will go to the next session. Okay, now see, next thing is intensity of light. Intensity of incident light. Okay, incident light. Okay, how it will depend? Intensity of, if suppose, if intensity of light, if you increase, what happens? Anyone? Intensity, suppose we are increasing the, suppose we are shining the light or incidenting some light, we are increasing the some current, we are increasing the intensity of a incident light. What happens? Sorry, someone is saying, what Amma, what are you saying?
Flow of electrons increases.
Yeah, more electrons eject. Okay, that is correct. Okay, good. So here, see, we'll draw a plot and you will understand. Okay, this is voltage, some voltage, or here this is some photo current. Okay, photo current. So if you increase intensity, more number of electrons will eject from the metal surface. If more number of electrons eject, means more current we will get, right? That is the use of intensity of incident current. Okay, incident light. Okay, if you increase the intensity, okay, this is suppose I1, intensity I1. Okay, after that we are increasing the intensity. So what happens? The saturation current or photo current will increase. But this stopping potential will not change. Okay, this stopping potential will not depend on intensity of light. Only this is suppose I2. Okay, first we increase, we have incident some light of intensity I1. After that we increase the intensity I2. After that we increase the intensity. Okay, this photo current is increased, but the stopping potential is not changing with intensity of light. Okay, here I3 greater than I2 greater than I1. So I3, I1, I2 is the intensity of light. So if you increase the intensity of incident light, intensity means they are having more energy. So if light is having more energy, more, it will eject more electrons. And if more electrons are ejecting, means we will get the more current. So if intensity is increasing, means we will get the more photo current. Photo current will increase. Okay, but this stopping potential will not depend on intensity of the current. Okay, here you have to make down 2 points. Okay, if you increase the intensity, photo current also increases. Photo current increases. And second point is very important. Okay, if you increase the intensity, stopping potential will not change, or Vs or V0 you can write, it will not change, okay? Or it will not depend, okay? Why it is not depending? Why the intensities stopping potential is not depending on intensity of incident light? Anyone, please think about this. Why it is not increasing? Please think of this one and tomorrow you answer me. Why stopping potential is not changing even if you increase the intensity of incident light? Okay, question is clear, right? Just think of
Yes,
it.
sir.
V0 is not changing. Here photocurrent is changing. So suppose in the first intensity photocurrent is up to here. In the second it is increased. Okay, this is increasing, right? This is increasing order. But here VOC all are reaching at same potential only, same stopping potential only. Why this is? Why not? It is coming some other places. Okay. Why stopping potential is not depending on intensity of incident light? Okay, please go through that question and please think of it. Why it is not changing? Why it is not changing even you increase the intensity? Okay, please think of that. Okay, next one. Next important, frequency of incident light. Frequency of incident light or incident radiation, whatever you can write is not a problem. Incident light. Okay, so how it will depend? Frequency. Suppose here we are drawing a, this is the frequency. Okay, this is the potential, some potential here. Suppose this is potential Vs and this is the frequency we are drawing. Okay, frequency we are drawing. So how it will depend? Frequency, how it will depend? Suppose you have different color light also. What is the work function definition? Work function?
Minimum energy required to inject the electron.
Yeah, very good, very good. Okay, what's your name? May I know your name?
Vishwanath, sir.
Vishwanath. Okay. Rule number?
535.
Okay, good, thank you. So here minimum energy H nu 0 equal to some work function W0, or you can write pi 0 also. It's what's this terminology, you can write anything, but you have to know what that mean. Okay, this H nu 0 is equal to, you can write W0, or H nu, whatever incident photon energy must are greater than or equal to omega 0 work function, that energy, minimum energy required to eject the electrons from any material or any metal or whatever. So first case, if incident energy H nu is must assured greater than or equal to work function, then only we will get the electrons. This photoelectric effect is possible. Okay. Then if it is H nu less than omega 0, this incident energy is not sufficient to pull the electrons or eject the electrons. Suppose let's take a example, simple example. You are here. Okay, you are here. There is a one stone, big stone is there. If you have sufficient energy only, you will lift this one, right? Otherwise you cannot lift this one, because you don't have sufficient energy, you cannot lift this one. Here also incident energy, suppose here electrons are revolving around the nucleus. Suppose this incident energy should higher than the work function, then only this electron will come out from the metal surface. Otherwise this will not come out, right? So this, when incident energy is lesser than work function, will not get the electrons will not get. This photoelectric effect is not possible. Okay, these two are very important conditions. So now here also this nu 0 h nu 0 is equivalent to work function, right? This nu 0 what we are calling threshold frequency. What is the threshold frequency? Okay, threshold frequency. What is this threshold frequency means? Minimum frequency required to eject the electron, or you can write minimum energy required to eject the electron. Threshold energy or threshold is equal to h nu, right? Is equal to h nu. This is you know. So frequency means it's nothing but energy only, right? Frequency means nothing but energy only. Minimum frequency required to eject the electron, that is the threshold frequency. Okay, you draw the diagram here. So okay, just you draw it like this, you will get a straight line. You will get a straight line. This is the frequency, minimum frequency mu 0, and this is the negative potential. This is positive scale, right? Upward is positive scale and downward is negative scale. So potential, stopping potential is negative. Here V0 or Vs, this is the V0, mu 0 is the threshold frequency. What is that? Threshold frequency. So depending on frequency also it will change. Okay, suppose we have whip jar colors. What we have? Whip jar. Suppose let's take a whip jar. We have different colors, right? Which one having higher energy in this? We have in this 7 colors, which one having higher energy? Please come on.
Red color.
Red. Red. What is the frequency? What is the frequency order? Red color frequency is lower or higher compared to suppose visible.
Lower.
Sir, lower.
So
Lower, sir.
Wavelength is more.
Lower, sir.
Wavelength is more.
wavelength is increasing
High.
and
More.
frequency is decreasing, right?
It's it
This is the
decreasing. Yes.
Must
so
be.
just see E is equal to h nu. So which one is having higher energy now? Frequency, which one is having higher frequency?
Violet.
That is
Violet.
violet is having higher energy. So this blue color is blue, or this is the increasing energy, increasing order, right? As a frequency is increasing, same order this energy also increasing. So blue is having higher energy, right? Blue is having higher energy and red is having lower energy, right? Like that also, if here also see, suppose h nu 0, suppose blue is having higher energy means higher threshold frequency, higher threshold frequency. Red is having lower threshold frequency, because this wave frequency also changing, right? So higher energy means they are having higher threshold frequency. Okay, you can write this is also. Here also you can draw diagram. You have experiment. In that experiment we will change the filters, different colors we will use, and we will find out the how these are changing. This is potential and this is frequency. You will get the, suppose this is the blue, sorry, this is the blue, red, or like this. You will get different threshold frequency. So this is suppose blue, this one green, red. Okay, suppose see, what is the blue color frequency? Blue, suppose if you take blue, what is the wavelength, or you can say wavelength also. Wavelength, what is the wavelength? Maybe around 300, 400, or 400 something like, right? 430 nanometers, right? About 430 nanometers. You can convert it to frequency also. So blue, here see this one, uh, mu 0, it is reverse, right? Is this correct one? Mu 0, mu 1, mu 2. Is this correct one? Graph I written blue, green, red. Is this graph correct? No, right? You got it? Point my point. What I am asking. So this is I am drawing 2, 3 lines. Just take 3 colors, any 3 colors. So blue is having E is equal to h nu, nu 0. Suppose blue is having higher frequency means higher threshold frequency, that is having. So this blue is blue here, red is here, and green is here, like that. Okay, depending on frequency, the threshold frequency also changes, right? Different color having, here point is to make out different color having different threshold frequency, different color having different threshold frequency. You got it? Point threshold frequency, or you can write mu 0 also. Okay, very simple. Here h nu 0 is equal to omega 0 or w 0, that is like a work function, minimum energy required to eject the electron from material. This is also threshold frequency, also one terminology. Minimum frequency required to eject the electron from metal. Okay, that is the threshold frequency. Below this threshold frequency, this below this threshold frequency, electrons will not emit because they don't have sufficient energy. Okay, you got it here point. Suppose less omega less than omega naught, we will not get the photoelectric effect. Omega should always greater than omega naught. Whatever incident light, suppose incident light frequency should higher than the threshold frequency, then only we will get the photoelectric effect. Then only photoelectric effect is possible. Is this point is clear to you? Is this point clear to you?
Yes, sir. Yes, sir.
Yes, sir.
Sir,
we have
repeat
we
it.
have we have different color of light, right? Different colors of light. So in that, each color having different frequency and wavelength, right? So minimum frequency, threshold frequency means minimum frequency required to eject the electron, like work function, same definition, same. Here we are saying in terms of frequency, there in terms of energy, that's it. Okay, incident color frequency should higher than the threshold frequency, then only that light having or that radiation having higher energy, then they are able to eject the electron from metal. Okay, in that case only this photoelectric effect is possible. Okay, if this is lesser than the threshold frequency, that energy is not sufficient to eject the electron, so in that case photoelectric effect is not possible. Okay, this is the point in we can conclude from the incident of frequency point. Next one. Okay, up to now clear, I think. Huh? If you have doubts, you can ask. Any doubt, please? So
Sir,
next one.
once again, explain the diagram, sir.
Yeah, okay. So here, see. So suppose here we are taking a frequency versus potential. Okay, frequency versus potential. So what is the work function means? Minimum energy required to eject the electrons from any work function is not only metal, any other also they are having work function. Minimum energy required to eject the electron. This is equal to omega or W0 is equal to H nu 0. Here nu 0 what we are calling threshold frequency. Threshold frequency, or you can write threshold frequency. Threshold frequency means minimum frequency required to eject the electron. Minimum frequency required to eject the electron. Minimum frequency required to eject the electrons. Okay, that is the definition of threshold frequency. Suppose if you plot the graph, okay, if you plot the graph, you will get the curve like this. Okay, here this negative, it's reaching to negative, right? This incident, this incident is here threshold frequency. This point is threshold frequency. This is frequency scale, right? And this is the voltage scale. This is voltage is negative voltage is stopping potential or stopping voltage, you can say. Okay, here this be less than this threshold frequency. This in this case, suppose here, suppose 10 hertz is there. Suppose 10 hertz is there. Okay, suppose this is a metal, you are shining some light, incidenting some light. This light having 5 hertz, 5 hertz frequency. Okay, this light having 5 hertz frequency. But what is the this metal? Suppose if you take any metal, this metal threshold frequency is 10 hertz. 10 hertz. Okay, right? The metal threshold frequency is 10 hertz, but you are incidenting some light of radiation 5 kilohertz. This is having 5 hertz. Okay, 5 hertz frequency. So in this case, this energy is very less. If you calculate energy, E is called h nu. Okay, h is some constant. Okay, some h into 5, right? Here you can energy is 5h, but here energy, what is the energy here?
10
10
H.
10h, right? So now this 5h is not sufficient to eject the electron because the metal having higher work function. So this is, suppose it is metal, or it is metal, to eject the electron from this metal, the energy is 10h, but you are incidenting light is 5h. 5h, so this energy is very less to eject the electrons. This is not sufficient. You don't have sufficient energy to eject the electrons. That's why it is not possible in this case. Photoelectric effect is not possible. Suppose here if you have same metal, same frequency 10 hertz, okay, you are using 15 hertz frequency of light. Suppose 15 hertz frequency of light. In this case, this 15 hertz is greater than the 10 hertz, right? 10 hertz. In this case, you have sufficient energy to eject the electrons. Okay, sufficient energy to eject the electron. That is what here you can conclude. Incident photon energy or incident photon frequency always higher than the threshold frequency. Then only photoelectric effect is possible. If incident photon energy or frequency is lesser than the threshold frequency, in this case photoelectric effect is not possible. Why? Because that photon having lesser energy to eject the electron from the metal surface. Okay, is this clear now? So like that, every color having different frequency. Every color having different frequency means if color is changing means frequency changing, frequency also changing. Frequency changing means threshold frequency also changing. Okay, different color. If you draw the line, you can have like this. Okay, different color having different. This is some different values different, right? Here different, here different. Okay, color A, color B, color C. These colors are different. These colors having different frequency means different. They are having different threshold frequency. That is the case. Okay, like what color we have? Vibjar, like violet, blue, green, like that. Every color having different threshold frequency. Okay, is it clear now?
Yes, sir.
Okay, next we'll go to the next one. Metals, different metals. Okay, how it will depends on different type of metals. Okay, we'll see now. 1 second, please. So different metals. Okay, different. Suppose we have here aluminum, zinc, and some other material. So on. Okay, so each metal having different work function. Okay, why it is depending on means each metal having different work function, or you can write e pi also, whatever you can write. It's, terminology different. Work function is different. Work function is different. Okay, that means what? Each metal, suppose if you take aluminum, you have to, this is having some work function, and if you take zinc, this is also having some different work function. Here suppose you may require lesser energy, here you may require higher energy. It depends on material, depends on metal, the work function is changing. So work function is changing means you have to, in that case, suppose you are taking metal A. Okay, here you have taking metal A. In this metal you are incidenting some photon. Here you need lesser energy, lesser. Suppose A metal and B metal, just I will draw it. 1 second, please. Suppose if it is a lesser work function, how? Suppose A metal and B metal, we are taking two metal. A metal work function is 2 electron volts, and B metal 3 electron volts. Suppose we have taken like this example. Suppose which one required higher energy to eject the electron? Which metal is required higher energy to eject the electron?
B.
B metal, right? So here you have, this is the work function. Okay, here you need more energy to eject the electron. Here you need lesser energy to eject the electron. So depends on metal work function. Here threshold frequency also changes. Threshold frequency also changes, and this potential also changes. This work stopping potential also change, and here work function also, this threshold frequency also change. That is the difference. Okay, if you take a different type of metal, you will see different type of photocurrent and threshold frequency and stopping potential. That is the dependence of metals. Okay, is it clear? Only one thing here, just if you take different type of metal, the work function is different, so you need different energy to eject the electron depending on our work function of the metals. Okay, this is the thing. Okay, now see here, total photoelectric effect. First one is, what is the stopping potential? Okay, stopping potential or stopping voltage, you can say. What is that? Second one, intensity, and third one is frequency, and fourth one is metals. Okay, metals, different type of metals. This photoelectric effect depends on these four type of parameters. Okay, now one more thing, this experiment Hedge proposal, right? Hedge discovered this experiment, and Einstein explained in theoretical way, and also Millikan and J.J. Thomson and others also proved experimentally. Okay, here what we know, what is the value of Planck's constant? What is the value of Planck's constant? H value, what is the value of H? What is the value of H?
6.626 into
Uh,
10 to the power of minus 34
For
joules.
yeah, very good. 34 joules. Okay. Now we have only value, but how this value is discovered? How this value is calculated? Which experiment they used? Using Millikan is also done some experiment. Millikan some oil drop experiment, something is there, and in this photoelectric effect also you can estimate the H value. What we know, Einstein's equation, H nu minus nu zero are into equal to EVS, right? EVS, or you can write Vs is equal H nu by E minus, here you can I am rewriting this expression, or, leave it, otherwise leave it. Okay, here h nu 0 by E. So this is how it looks like. Y is called mx minus c, Here we will take voltage or stopping potential. Here we will take the frequency. Suppose if you have different color, frequency is different, right? You make out these 3 points. Okay, or just okay. Suppose you first you take the blue light or red light. Here the work function, suppose here is the threshold frequency, and you take blue light, green light, here is the threshold frequency, and you take red light, here is the threshold frequency, right? Nu zero. But we are taking only one metal, suppose Al, but color is different. This is red, green, blue color. So you join these points, and you will get the, here from this curve, someone is unmuted, please mute. Okay, in this graph you can find out slope, and you can find out the slope y2 minus y1 x2 minus x1. That slope you compare with this relation. You compare these two equations, and slope is what here? Slope is equal to what? Slope is what? Equal to what?
is equal to Yx plus C.
Yeah, slope is m, right? M is equal to what is here? H by E, right? H by E. From this equation, H is equal slope into E. Slope into E. How will you get the slope here? Just from this graph, you are plotting the graph potential versus or stopping potential versus frequency. Stopping potential versus frequency, and you find out slope here from this graph, y2 minus y1 by x2 minus x1. Okay, from this slope you substitute here, you will get the h value, and you compare this with other experiment. Okay, using this photoelectric effect also you can estimate the Planck's constant, right? Is it clear? Just we are Einstein's equation, we are plotting the graph voltage versus potential versus frequency. From there we are taking slope, and this equation we are comparing with linear equation. There the slope is equal to this one, h by E. From there we are calculating the Planck's constant. What we are estimating? Planck's constant. Okay, this is the way of estimating the Planck's constant. Is this clear, everyone? And one
Yes.
I raised two questions. Why stopping potential is not depending on intensity, Second question also I am asking, is it possible only metals? This photoelectric effect possible only for metals? Please write question only for metals, or you can do it insulators or semiconductors. Insulators and semiconductors. Please go through these questions or semiconductors. So first one is, why stopping potential is not depending on intensity of incident radiation, and second one is, this photoelectric effect is possible for insulators and semiconductors. Why only it is possible to metals? Why not insulators and semiconductors? Or is it possible or not? Just you ask, you look at it. Okay. Is it clear? Questions are clear.
Yes, sir.
Sir.
Now we have discussed
Yes, sir.
we are discussed only for metal. Is it possible to get the photoelectric effect for insulators and semiconductors? If it is not, why? If it is yes, why? Okay. How it we will get? And also first question already you know. Okay. You please go through these questions. You have to answer these two questions tomorrow. Okay. Okay. Then I'm closing the class. Bye bye. See you.
Thank you, sir.